Hello Algebra 1. This is the first of two videos that you're going to have to watch tonight. So I'm going to try to keep this as short as I can. But this is a topic that's caused people some confusion, so I have to make sure that I'm thorough and clear as well as quick. This is the third time now that we've talked about word problems, and this will be the last time, but I want to make sure that I've talked through some of the word problems that I assigned as homework last night, because some of them were causing some people some difficulty. So this is straight from chapter 1.5, and the first one that I'd asked you to solve was on the bottom of page 31, and it's this story about Jerry. And Jerry has 4 different grades so far on 4 different exams. He also is about to take another exam. This one is worth 200 points, and it counts as 2 tests, not just one. And he wants to keep his average at 80 points. They aren't asking us to figure out what his average is so far. If they did ask us that, we would simply add up the 4 scores that we have and divide that by 4, but they haven't asked that. They want us to help him keep his average up with this additional test. Well, here's, and you'll probably remember that we've worked on a similar problem right from page 31, like this, where we said, here's the space where we're going to put in a value for that extra test. And as this indicates, we're going to divide by 6 now. We're not going to divide by 4. We're not even going to divide by 5. The reason we're dividing by 6 is because this new one counts as 2 tests. It's like a double test. So the guess, check, and revise method was the first technique that the chapter and actually the textbook suggested for working with word problems. So let's talk that through. I'll show you that, and then I'm going to show you a faster method a little bit later. We've got to guess some number to put in here and see if that's going to keep us at least 80. Well, since we're allowed to guess anything, I've just guessed the best score he could get, which was 200. So go ahead, put this into your calculator, and figure out what's his average if he does get a 200 on that last test. Okay, I'm going to assume you did that, and you should have found that his average was 86.6 repeating. Well, that's actually higher than it needs to be. In fact, we're asked to find the lowest score that keeps his average at least 80. So we can go all the way down to an average of 80.0. So we can try a lower number. Well, we've done guess, that was the 200. We've done check, that's the result that we got. Now we're about to revise. We're going to revise our guess. Let's try 140. Go ahead, hit the pause button, and when you come back, I'll show you the result, the average that he gets for that. Okay, there's that answer for that. I'm assuming that you've worked this out, and you should have gotten the same answer. 76, actually have done this beforehand. I can't remember now if it's 76.6 repeating or if it literally stops at 0.6. I think it's 0.6 repeating. I think this is a mistake. But either way, that's clearly too low. He has to be at least 80. So this one didn't work either. So we've guessed twice. We've checked twice. Well, now we're about to revise again. That's the thing about the guess, check, and revise method. You just keep going, and you keep throwing darts until you happen to hit the one that works perfectly. There is a faster way. Let's talk about that now. Remember, we had this slide earlier where we just had added up the 4 scores that he's already gotten, said that we were going to put some number in here and divide by 6. Well, instead of guessing what that number is, what if we just put x in there? But we know that it's supposed to be at least 80. Well, the lowest number it could be then is 80. It could be higher than 80, but it's got to be at least equal to 80. So what happens if we set it equal to 80? Now what happens if we try to solve for x? The first thing we would do would be to multiply by 6. So we've moved the 6 over here. And so now, if you keep going and want to solve for x, now what you have to do is move all of those things over. Well, at this point, it's just going to be easier to add all of those things up. And those things on the left, those 4 original exam scores that he got, add up to 320. So now we've got 320 plus the x equals, well, 80 times 6 turns out to be 480. Well, if we have this, now it's easy to solve for x. And you showed me that on your most recent quiz that you all know how to do that. X turns out to be 160. That's the answer that you would get through guess, check, and revise, but you get there a whole lot faster this way. There's often a faster way than guess, check, and revise, but just keep that technique in your back pocket, because sometimes the faster way isn't necessarily the more accurate way, and you might get confused. Guess, check, and revise will always work, so it's not a bad technique to know. Here's the next problem I asked you to answer. This time I'm going to suggest a different technique. Now I'm going to talk about verbal models. And why don't I have you hit the pause button and read this paragraph and make sure you understand the question before I go farther. Okay, I'm going to assume that you did that. You notice these pieces of what I call the verbal model look like notes, and that's the way I think of the verbal model. I think of it as simply a technique for good note-taking, and then I can move these pieces around, almost like they're on index cards, and try to decide, okay, how am I going to arrange these? Whoops, didn't mean to move that one. How am I going to arrange these so that it makes some sense? Well, ultimately, what I ended up deciding was to read the question one more time to myself more carefully and figure out what I'm being asked. And here it is. It's a mouthful, this last sentence here. How many times must a person visit the museum for membership to be less expensive than paying for each visit as a non-member? If you stop and think about it, really what we have here is a competition between two options, the membership option and the non-member option. And I'm trying to figure out, how do I get it to the place where the membership option is a better deal than the non-member option? So what I want is to compare these two. Well, here's my notes about the non-member option. It's really just $8 a visit. It's simple, but it's expensive in some cases. The member option has two pieces to it. It's the $40 member fee and the $5 per visit fee. Now, what I want is for this to be more than these two things put together. And if I'm putting these two things together, what I'm really doing is adding those things. Because remember, what I'm doing is I'm paying a member's fee and $5 per visit. One way of interpreting "and" in math is to make it a plus sign. Okay, well now I've got this set up, and I'd like to solve it. Before I go farther though, remember, it's hard to set up an equation, and we've talked about this in a previous example, when it's an inequality, and what we really want is this balance, this tipping point, where this is just a little more expensive than that, because that's the place where I make this switch and I decide to get my membership fee. When is this equal to that? Because one more visit will make this a better deal. Well, so let's make that equals. It becomes a whole lot easier to solve if we set this up as an equation. Now my left side is 8 times visit, $8 per visit. And that's equal to $40 plus $5 per visit. From here, I can solve for v, and I can figure out what the number of visits is. I've got to get the 5v together with the 8v. I move it over by subtracting. Now I've got 3 visits equals $40. And that means if I want to divide, I'm sorry, not 3 visits, $3 per visit equals $40. My bad. So now I want to know what the number of visits is. So I move the 3 over. Oops. Move the 3 over by dividing, and you should have found that v equals 13.33. It's easy to think you're done now, but there are 2 tip-offs that you're not done. First of all, what in the world is 0.33 visits? There's no such thing as 13.33 visits. That doesn't make sense. Second of all, remember, it wasn't an equation in the first place. I wanted this to be more expensive than that. I wanted this to be the better deal. Well, that means I've got to figure out, what do I do? Because I'm going to be using whole visits. I can't just dip my toe into the museum and leave. I'm either paying or I'm not. I'm either going to do 13 visits or I'm going to do the next one more, 14 visits. Well, it turns out, if you think about it, the 14 is the place where it's going to tip. At 13, it's not quite there. At 13 visits, I'd still be better off paying each time. But at 14 visits, this becomes more expensive than this deal. You can always double check that by plugging this in. Try 14 times v right here. I'm sorry, 8 times 14 right here, and 40 plus 5 times 14 right here, and you'll find that the 8 times 14 is a larger number, and this becomes the better deal. Okay, one last word problem. This is the story about Jeff living in this state where speeders are fined this amount. Pause, read the problem to yourself, and then I'll explain. Okay, I'm going to assume that you did that. The textbook this time nicely gives us the verbal model. And this is the way they've written it out. So now, from here, it's simply a matter of plugging in the right numbers to turn this verbal model into an algebraic model. Well, to pick the right numbers, you're going to make sure you understand what the question is. The question is, how fast was Jeff driving? So, let's make sure that we've plugged in the right numbers. Why don't you hit the pause button and see how you set up the algebra, and then I'll show you what I've done. Okay, I'm going to assume that you did that. Here's how I set it up. $20, that's the fine for every mile an hour over the speed limit. X, I don't know what the miles over the speed limit is, so I had to put in someplace over I picked the letter X. But I do know the amount of the ticket, that's $260. So now I just need to solve for X. I divide by 20, and X is going to turn out to be 13. So what does that mean? Well, don't get caught up in thinking that he was going 13 miles an hour, because that doesn't make sense. Nobody gets a speeding ticket for going that price. Remember, it was miles per hour over the speed limit. He went 13 miles too fast. So if he wanted to know how fast he was driving that 13 miles too fast plus the 45 that he was allowed to drive. He was actually driving 58 miles an hour in a 45 mile per hour zone. That's why he got the fine. Okay, there are a couple of other word problems that were assigned to you last night. This was a two-question problem about mountain biking, 59 and 60. And then there was also question 61 about the basketball team. I'm not going to go over these in this video. Instead, I'm going to ask you to bring in your answers to those as part of your homework. I know you brought them in last time, but we didn't go over them. Bring them back, and we're going to go over these in class.